No, it's not. So good thing I checked. We're also going to be building a RESTful application, so that way our front end is able to interface with our back end when we start doing that. Front end frameworks, we're going to be looking specifically at React, but a lot of these things that we're going to be doing are going to be the same for like Angular or Vue. The way that we write it would be different, but a lot of the same principles will still apply. Nodejs, we're going to be going over, and the battle for JavaScript everywhere. As I said, you can write code once and you can reuse it both in the front end and the back end, but you also only have to know one language. So that's pretty good because, like I said before, you would have to know either 2 languages if you're going to be a full stack developer, whereas now you can have people that have experience on the front end that are now able to do code in the back end. Maybe they're not the best at it, but they are able to do stuff. We're also going to be going over NPM and node modules. So this is the ability to download other people's code into our project and be able to reuse it so we don't have to reinvent the wheel. Git and GitHub best practices, and hopefully having fun. So with that being said, I'm sure you guys know, your second year, we're going to have to go over the syllabus. I'll just quickly go over where stuff is on Blackboard and just some other expectations in the class. So just give me 1 sec. Also, do you guys have a preference? Do you want 1 break or 2 breaks? 2? Vlad has decided 2. If anyone, feel free to fight Vlad. Vlad decided. If you guys want to change it week to week, we can do that. So after the first hour, I'll do a 10-minute break, another hour, 10-minute break. Okay, so the syllabus, I have yet to post this on Blackboard, but it will be up there at the end of the day. As you guys know, we're in E118, or is it 116? I might have mistyped. Sure, it's 118. So here's my email if you need to contact me. Because I'm a part-time instructor at the college, I don't actually have office hours. So if you need to get in touch with me, you can either do it over email, as well as I invited all of you guys to a Slack. Yes?
Can you add another email to Slack?
No? Oh. Yes. So I invited all you guys to Slack, and what that is it's like a collaboration tool. I don't know if you guys have used it here or not. Some teachers do, some don't. But what we're going to be using it for is if you have like a quick question, or even if you just want to like shoot me a message going like, hey, I'm just running late, or really just anything. Usually for me to respond back in email, like I wouldn't just respond back saying, okay, if you said, can you check my code? But I'll let you know that, yeah, I got that message, and then I'll do it later. Typically, because I work 9 to 5, I can't necessarily do something right when you message me, but just letting you know that I got that message is probably beneficial to you guys. As well as, because this class and yesterday's class is the exact same class, if you have anyone that you want to do a group project with between the 2 classes, you can do that. Because we're not in the same class, you can use Slack as collaboration to being able to work on that. Yeah, I'm sure you guys kind of get it. It's like, I don't know if anyone used MSN back in the day, if you're not familiar with it. So the expectations for success, just, do the work. This class is pretty easy to do if you do the work. And if you don't, then, I mean, you will either get a low grade or not passing grade. The assignments, everything in this class is going to be practical. There is no midterm, there is no final exam. Everything is practical. There will be 2 assignments, a group presentation for better or for worse, and the remaining 25% will be made up of labs and quizzes. Yeah. So as I said, I don't have any office hours, and the evaluation of quizzes and labs is 25%. First assignment, also 25%. Second assignment, 25%. Final presentation, 25%. It's a pretty easy breakdown. Assignment 2 is a group project, and the presentation is a group project. So 50% of your mark will be in group projects. If for some reason you want to work alone and just do more work by yourself, feel free to. I encourage you, of course, to also just work in groups, though, because when you go out into the workplace, you're not going to be able to have that luxury of just working by yourself. You're going to work with people that you might not like. I had to work with Vlad. Sorry, Vlad. You're the only one I know. I gotta pick on you.
It's fine. I get used to it, every single lesson.
So yeah, so when it is not a group project, of course, you are expected to do your own work. Any sort of like catching of plagiarism can be anything from an automatic 0 on the assignment to even a 0 in the class. Yeah, so I had a couple students last semester who got caught for plagiarism and got an automatic 0 in the class and then suspended from the college. So I please encourage you to do your own work. It's way more work if you don't. So here's a weekly breakdown of what we're going to be doing. Let me just bump up the font size for you. So today we're going to be going over what is the MERN stack and the cloud. There's not really much to the cloud that we cover today, but we will be deploying our applications into, has anyone here used Heroku before? A couple head nods, probably people that have worked in Node before, I'm guessing. Next week is more of an actual intro into Node.js. Today we're just going to be going over a brief overview of kind of the whole ecosystem of how it works. And then tomorrow we're going to dabble a lot more with it. There's not actually a holiday. That was from yesterday's class. So this class, just because to keep on a consistent schedule with the other class, on the third week, we're just going to probably just do like small recap and just kind of go over what we've done. It'll only be 2 weeks, but just to make sure that both classes are on the same schedule, it's not going to be as much. Then after that, we're going to be going over Express for our HTTP server. In fact, we could probably just move that into here and then cover it both days because there's a little bit to Express. Then we're going to be going over CRUD with Mongo for 2 weeks, authentication part 1, then midterm, authentication part 2, React, and then at the very end will be the student presentations. So, and whoops, I had removed this, lab 3. So there will be 4 labs in this class. I might just throw in like a quick quiz just to make sure that you guys, is that rain? Or no, we're on the first floor. I don't know, that's quite loud. Anyway, I'll just do possibly a couple quizzes just to make sure that you're where you're supposed to be, and I can just, again, kind of gauge where you guys are at. And yeah. So emergency evacuation, we only have 1 door in this classroom, so just make sure that we do it at a steady pace. Lockdown, as opposed to my other class, which most of the wall is just glass, we just have a tiny little window. So if we need to hide out in here, we can. As you guys know, the rules at the college is get out, hide, and then fight. If for some reason there's a lockdown and there's someone that is in the school that's crazy. As well as sexual violence procedure and protocol. This kind of encompasses everything. The campus, of course, is an open space, so free from harassment, free from really anything that's kind of hopefully judgmental. So if for some reason you feel like you're being harassed or something like that, either if it's something that is specific in this class, feel free to just let me know. Hopefully you're comfortable in doing so. If not, of course, you can always contact different people in the college, such as the program coordinator or possibly someone else. For unscheduled campus closure, I do have to cover this just because if for some reason the school were to be closed, probably not going to happen because we're not going to have as many snow days, hopefully in the summer. But if for some reason the college is going to be closed, they do announce it across all the different platforms, the website, radio, Blackboard, email. And these are the times in which they will notify you by. If for some reason this class is going to be canceled, I will both message on Slack and use Blackboard with the email, so that way you get a notification letting you know that class is canceled. Certainly hope that it won't, but if something were to come up like an emergency, I'll try to let you guys know as soon as possible as not to waste your time, because I know some people can take quite a drive to get here. So. Does anyone have any questions thus far? There's one more thing that I was going to cover, which I might have just scrolled by. But is there any questions right now? Okay. So in here, if you are late for your assignments or like anything that is submitted, it is a 10% late policy per day. So with it being due on Monday, if you submit it on Tuesday, even if it's at 2 a.m., that is 10% off the final grade. If you need an extension, try to contact me before the night that it's due. I will try to do everything I can to make sure that you can get it done. Sometimes people wait till the last minute and they feel overwhelmed. Hopefully, you won't do it, but I know that sometimes other classes do come up and you have other priorities and life also just can happen. So if you need an extension, try to get to me, hopefully not the night before. Otherwise, I would like hopefully a doctor's note, or if there was a family member to pass, some sort of thing. Otherwise, you're going to be getting 10% per day. Is that clear? Just make sure. Cool. As I said, an overall grade is 50%, as well as you guys will need a 60% overall average in your program. Let's see. And while this is very strict, I promise that I can be flexible. So don't feel too stressed about trying to get stuff done. Also, because this usually happens every semester, if you're working in a group project and someone is not pulling their weight, please let me know as soon as possible. Sometimes that person can have a busy life and maybe they're not doing their job, or sometimes they're just slacking off. So if you let me know ahead of time, I can hopefully talk to that student and make sure that they're pulling their weight. Otherwise, I can mark you guys separately for the work that is done. Because we're going to be using GitHub, I can see everything that both you and that individual have contributed to the project, so I know what they've contributed. When it comes to doing like an actual presentation, obviously I might not necessarily know how much they contributed, but the actual code I will be able to see, so try to let me know as soon as possible. And Blackboard, okay. So in Blackboard, as you guys know, there's going to be the weekly learnings, which is where we're going to be putting in the stuff that we get to it. So the slides that I'm going over today are going to be there. Under submissions is where you will submit your assignments or labs for the class. So here is the submission for lab 1. You can submit it as many times as you want, but all the code is going to be on GitHub, so typically you only need to submit it once with your GitHub link. I will, even if you, so some teachers expect you to submit like a zip file of your code in addition to a GitHub link. I don't want that. I just want the GitHub link, and I will mark anything up to like 11:59 that night. So if you submit it at 10 o'clock, realize that you messed something up and you have to push code up at 11, that's totally fine. It's still before the day that it's due. But if for some reason you have submitted code, fixed it after the fact, and you do want it still marked past the due date, losing 10% or 20% or whatever, please just resubmit it so that way I know. Once I have marked it, I won't know that you want me to remark it, because like GitHub doesn't let me know that. Only Blackboard will let me know that something needs to be marked. So just for reference, I can quickly show you guys. I think most teachers probably don't, but I have a grade center. So not the grade center, needs marking. That's what I need. So in here, there's nothing. This is what will show up when you guys submit something. So if it's not in here, then I don't know to mark it. Of course, you can just send me an email if there's some sort of issue, but otherwise, I need to know to mark it. Any last questions? No. Okay. So I'm going to be going over the slides for what is like the MERN stack. So I just have to find that here. Give me a sec. And I also do apologize in advance because this class is usually the most boring because there's the most that you have to go through. So as I said, JavaScript frameworks. I'm going to be going over the MERN stack, Node.js, and NPM. As earlier mentioned, MERN stack is Mongo, Express, React, and Node. As I said, it'll go, Mongo is for the database, Express is for the HTTP server, React is for the front end, and Node is for the actual server part of it. So these are the building blocks that are used by, these building blocks, Mongo, Express, React, and Node, are all built by different teams. So in the JavaScript community, a lot of stuff is done open source. React is actually an open source project that's done by Facebook. And Node is done by, it's now owned by the Linux Foundation as completely open source. Express is just a module that's just someone threw up there just to make it easier to do an HTTP server. But all of these are done by different teams, which is sometimes great and not great, because sometimes one team will want to implement something that might conflict with something else. But I mean, for the most part, they are kind of all in their own ecosystem. This kind of more goes into other modules that you can use. But because React is mostly on the, or is traditionally only used on the front end, it won't really conflict with anything that we do on the Node side, because that'll be on the server. But the main strength of having all of these is the fact that JavaScript is the main programming language for all of them. The only problem, as I said, is sometimes connecting these tools together can be a little bit of an issue. So you guys have gone over probably different patterns for making a website. The most common one, especially these days with like Node, is the MVC pattern, or using data, logic, and presentational. So we'll have some sort of logic that will be in our controllers for either manipulating that data after the fact, or even just for the initial calls of grabbing that data. Then we're going to have the presentational aspect of it, which is our HTML markup that we'll plug our data into. But that's pretty much how everything is usually split up. So typically it used to be database, server, and client. But because of more complex requirements for web applications or even just websites, it's now kind of almost split into 4 parts, being a database, our server logic, our client logic, and our client UI. So as mentioned, the popular paradigm of implementing this is MVC of our model, view, and controller. The controller part is where really our nodejs is the majority of it, whereas our view is most likely going to be more React or just HTML. And then our model is going to be the mongoose. So here's a quick diagram. I'm sure you guys kind of know, hopefully, MVC by now. You guys, when you did C#, did you guys use MVC or .core? MVC? Did you guys also do web forms for the first, or no web forms? Don't remember? Okay. But this is pretty similar. So instead of doing it in C#, we're going to be doing it in JavaScript, where when you hit the website, it'll hit the controller. Controller, calls the model, which will grab data, which then gets passed into our view and sent back to the user. So when it comes to MERN, the concept behind it, again, is JavaScript-driven solutions, which has the advantage of just being a single language, and all parts of the application can support and often enforce the use of the MVC architecture. And in previous ways, you had to serialize and deserialize the data that's coming back from the models, or for the data, in order to being able to use it on the front end. So we would have to convert whatever structure our SQL or NoSQL data is in order to use it in JavaScript. However, because everything is already going to be in JavaScript, we don't have to do any sort of conversions in order to use it. We're going to be working with JSON objects, which stands for JavaScript Object Notation and represents data in JavaScript. The reason for this, this is going back way forever ago, is XML, which was used for being able to represent data. I don't know many things that actually use XML nowadays, but the reason that we switched to it is that it's more readable. XML is kind of like a tag system similar to HTML, where you would tag everything, whatever you want to call it. But with JSON, it's more readable. It's also lighter weight, so you have to send less stuff to the user. It's faster because it uses less bandwidth. And MongoDB is able to just store our JSON in binary format, just right on in the database. So here is a quick example of JSON. It's just two squiggly brackets, and then you have a key and value. So in this case, username would be our key, and your user1 would be the value, et cetera, going down. And then it has the square brackets because it's an array. So this is an array of two objects. Pretty straightforward. Any questions thus far? You guys have already done the JavaScript fundamentals, so I know a lot of this is just recap, but sometimes... Oh, is anyone here actually not in computer programmer or analyst? Okay. Previously I was teaching the web design program, and there was actually some people from programmer that was in it, so I wasn't sure if there would be some overlap from there here. So when we're using the MERN stack, instead of just hitting the controller by itself, the user would actually be interacting with reactjs, which would then be hitting our server. So we would be able to manipulate the DOM using reactjs, which would then hit our controller. It hits the Node.js server, which technically expressjs is kind of wrapped around it, not necessarily to the side. But just for this demonstration, it's a little bit easier to see it. So, intro to Node. So, Node.js came because of Google updating their rendering engine for JavaScript, the V8 JavaScript engine, in 2008. And the main thing is that it was really fast compared to before. So JavaScript used to be pretty slow in most things, which is why when you tried to interact with a lot of websites, probably say like pre-2008, even going back to like, let's say like early 2000s kind of thing, it was pretty limited on what you could do. Because JavaScript is not compiled, it is parsed and executed at runtime. So what that ends up being an issue with is that it has to parse all of your JavaScript and then execute it. And in doing so, it was pretty slow. Luckily, in 2008, Google had updated it, and it was pretty quick. And in doing so, we were now able to do more complex things. Because of the speed increases, JavaScript actually became a viable programming language to use on the server side. It's still, I mean, you know, if every problem is a nail, you're going to use a hammer, and JavaScript can solve a lot of problems, but it's not always necessarily the best tool for it. But you can still use it, which is pretty great. So the one thing that developers wanted to do was non-blocking sockets in JavaScript, and there's a lot of different things that you can do in JavaScript for non-blocking code, such as promises. And they took the V8 engine, wrapped it around already solid C code, and created the first version of Node.js. So Node.js actually started a pretty long time ago. It was in beta for, well, probably alpha forever. It went pretty stale, and then no one was really working on it. And then a side project came that updated it. It got merged in, and now it's a part of the Linux foundation for developing it. So it right now is at version 12, which will be LTS at the end of the year for long-term support. So it's not going anywhere anytime soon, hopefully, because I like to have my job. So, so with that, so JavaScript is an event-driven programming language. As you guys have probably seen, you can attach an event to a button, and when you click that button, code will execute. So that's the whole idea of where JavaScript started. Is something happens, I want to do this. There's other programming types that you can do in JavaScript. You can do a more kind of like functional programming. You can also do object-oriented programming. JavaScript, as I said, it can do a lot of things, and you can write JavaScript in a lot of different ways, trying to please everyone. You can do classes, kind of similar to you guys in C# and Java. You can do more kind of like functional programming, kind of a little bit like Python, but not as Pythonic. And then, of course, you can just do like event-driven programming by listening to events. So this concept allows you to seamlessly execute asynchronous code without blocking the rest of the program from running, because if you're waiting for something to happen, nothing is happening at that time. There's a YouTube video from Code School, which we're not going to watch right now. But Node.js, at its core, was originally intended for when something happens. So if you're using certain parts of Node.js, you'll see that it uses like streams a lot, where you're trying to execute something, and then on every stream that comes in, you want to execute something based on that, but there are tons of different ways that you can do it. So NPM. So Node.js, was getting popular, and people wanted to be able to reuse their code. If you look at any kind of popular programming language, they all have their own package managers. So I think it's just ASP.NET in general has the NuGet package manager. Python has pip. There's tons of different ones. Go has its own. Rust has its own. And Node also has its own called NPM, which stands for the Node Package Manager, although if you go to their site in the upper left-hand corner, it changes every time you go there with a different acronym of NPM. So to achieve more complex functionality, they made a module system that allows you to extend the platform, so that way you can just install code into your website or into your application. And what's great is if you're using the same code across multiple applications, you can just update it once, publish it to NPM, and you can re-pull that down into all your applications. You don't have to make a change and then copy paste that across all your applications. So as soon as you update a bug once, it hopefully fixes it for the rest of your applications, as long as your applications aren't relying on that bug. So the best way to install, update, and remove Node.js modules is just by using NPM. There are other package managers that you can also use. Facebook has their own called Yarn. It used to be a lot faster than NPM, but NPM has gotten a lot faster over time. And also the two main features of NPM, which I will show you just right now, is they have a registry online where you can browse, download, and install third-party modules. So you can just go to their website and see what's on there. As well as they have a CLI tool that is used for managing local and global packages. So we have the ability to install some global packages. I'll just quickly show you what NPM's website looks like. So it's pretty basic. They just have the search bar up at the top, and you can search whatever package that you want. In this case, we're going to be using Express as one of ours. So you can just search Express, pops up here, and you can see all the information for it. So in this case, in the last week, they've had 7.4 million downloads for this. You can see its dependencies, what is depending on it, how many versions there are, and what those versions are. And usually, if you're using hopefully a good package, it has a pretty extensive README. Sometimes it's on NPM, sometimes it's their own external documentation. But usually they give you a quick rundown on how to use it. So we'll be using this for different parts of our application. In a lot of cases, there's a lot of stuff that's already solved. One of the most complex things, not most complex, but one of the most annoying beginner issues to deal with is dates in JavaScript. There's a lot that's kind of wacky with them. So there's a pretty good library that handles a lot of stuff for dates for us that's called Moment. Some people don't like it just because of how large it is. There's a lot that's to it. But in this case, this is a package that has its own external documentation. But there's a lot that's pretty cool with it. So you can just give it a date, or in this case, you can just say moment. You call it as a function with nothing in it. It would take the current time, and then you can format it. And it gives you a bunch of different values that you can format it in. So you can say January as a full word. You can have it so that it says first, second, third. You can also do the day of the week. As you can see, there's a lot that you can do that this library will already solve. So programmers, I'm sure as you guys know, are pretty lazy and don't want to solve the same problem over and over again, especially when someone else has already done it. So if you're being paid to get a feature out the door, it can take quite some time to sometimes do a lot of complex state stuff. So in this case, Moment is a good solution of being able to just handle that. So when using NPM, there's a bunch of commands that we're going to be using in our terminal. Most important one is install. Of course, this is going to install an NPM module off of the registry. You can also give it a -G flag, and that will install it globally. So at the example at the bottom is us installing npm install express for the express module that we just saw. So the preceding command will install the latest stable version of the express package into our local node modules folder. This is going to contain everything that is a dependency of our application that we're going to be using. So in some cases, you can sometimes just install one module and it will install a bunch of other modules already. So I just reopen that. Not moment, but express. So express right here, you can see under dependencies, it has 30 different dependencies. So all of these dependencies sometimes will have other dependencies. So you can open up context type. This one has 0 dependencies, maybe cookie might be 0, array flatten, 0. One of these might, I'm sure. So this one, serve static. So this one has 4 dependencies. So in order to use Express, you also have to download all 30 of these dependencies. And if any of those have dependencies, it'll have to install those, so on and so forth, down the tree you go. So very quickly, you can install a lot of things. And sometimes like the files are pretty small. Like it just might be like, part of a kilobyte of something that just does one thing. In this case, array flatten probably just does one thing. It will take a multi-dimensional array and just flatten it down into just one flat array. That's its sole purpose. But in order to not have to write that function from scratch, someone will just install it in. So the other thing that comes into installing a module, as I mentioned, there's versions. So you can specify what version you're installing. That when you type in npm install, you would type in your package name. In this case, this would be Express. Then you can do an @ symbol and say what version you want to install. So npm uses semantic versioning, which follows a pretty easy principle. It has a number followed by a period, a number, period, number. And there's a site that's called semver.org that has a lot that kind of like explains. There's a bunch of like rules that's to it. Nothing's, I guess, not really fully agreed upon. A lot of people will do semantic versioning their kind of own way. But the principle is pretty basic. You have a major. So in this case, we would have a major of 2, a minor of 0, and a patch of 0. So if you're working on a project and you have a bug, and it's not working as intended, so you end up fixing that bug, you would typically only increase the patch number. So in this case, we have a bug in semantic versioning. We increase it to 2.0.1, meaning that we've now just fixed and released a new patch. But if you want to release a new feature, typically that's when you would increase the minor version. So it would become, as soon as you increase the minor version, the patch number will go back to 0. So that would become 2.1.0. And then a major means that it's not backwards compatible. So if I'm relying, let's say, on Express. So Express, I'm using it across my entire application. They come out with a new major version. That means that my code will potentially break without making any changes to it. So what's nice about using semantic versioning is very quickly you can say, I want my application to always install 2.0, I don't care. So you can say, as long as it's in the 2.0 range, I can install as many patches as I want, so that way I always get bug fixes, but I might not necessarily get new features. You can do the exact same thing with the minor version, saying that I want new features and I want bug fixes, but I never want to increase to the latest major in case if that were to break. And then of course you can just free do anything and just say like, I don't care, I'll fix it. At the end of the day, it doesn't really matter. This class is just for learning. There's probably not going to be any major issues that break our application during this class, but if for some reason it happens, that's kind of just how it works. So, and these rules aren't necessarily true always. Sometimes you can just increase a major if you feel that it's enough code has been released that it's kind of the next iteration of your product. It doesn't necessarily mean that it's not backwards compatible, but the proper rules is if it does break, you have to increase the major. So That was a lot of talking. So in our project, and I think it's on the next slide if it shows me the preview. Just give me one sec. No, we'll get into it. We also have a file that is going to house all of our dependencies that's in our project. It's going to be called package.json, which is a JSON object containing all of the metadata that's in our application. So it's going to be like the name of our application. This is where we can manage our own version number if we were to release something, as well as our dependencies. Because, as I said, as you just saw, we have 30 dependencies that's in Express. Each one of those can have its own dependencies. We don't want to be putting these dependencies onto GitHub. Our projects can get quite large. So what this file does is when we download our project, we can just npm install and it will automatically install everything that is in our dependencies. We don't have to worry about individually going through and installing each one. And in doing so, when we use double dash save, this is telling npm to update our package file and put that dependency inside of it, so that way we can use it in the future. Without doing so, although there is some things where I can't remember which version, by default it might just actually update your package file, but you can npm install a package and just test if it's what you're wanting to do. Sometimes we'll install something, realize that it doesn't fit what we're trying to do, and then just uninstall it. But we don't actually add it to our package file. And that's where we come into uninstalling. We can just do the exact same thing and remove it from our project, or uninstall it globally. So typically most things that you'll install globally will be like CLI tools. Has anyone here ever used Create React App before? One person. Okay. So Create React App, what it does is it scaffolds out an entire project for us using React, so that way we don't have to do it because it's a pain in the ass. And you can do it with like Express, and there's a bunch of other tools. Angular has their own CLI, Vue has their own CLI, and all of these are so that way people can scaffold up a project really quickly and just spend more time developing and less time configuring. We can also update if we choose to do so. Usually you just kind of go one by one and just update them, or even just check the version. You can also check, I believe it's npm outdated. You can see which modules are in your application that don't have the most recent version. And npm has also been doing like an auditing tool of if there's any known vulnerabilities at that version, it will let you know. So sometimes keeping up to date your modules can be helpful, but is not necessarily necessary. So as I mentioned, there's a package JSON file, which is just installing a single package is nice, but pretty soon your application will use several, and that's where you want to manage your package dependencies. For this purpose, npm allows you to use a configuration file named package.json in the root folder of your application, and this contains, like I said, the metadata of your application. So here is a small example of it saying, name and version, and then the dependencies in your application. So it's just a flat JSON file that contains the different attributes you'll need to describe your application properties. Whenever you run the commands from the terminal, it automatically updates it for you. You don't typically have to manage this by hand. That's way too tedious. But we do have to create it. So at the very beginning of your project, you'll type in npm init for initializing your project. And it will ask you a series of questions, such as the name of your project, the version, description, entry point, meaning like where does your project start, what is the main source of code that uses everything else. A test command, a Git repository, which you don't necessarily have to set up. This is more for when you're trying to publish into NPM. Some keywords if you want to, an author, and the license of your project. The easiest thing to do is you can just type in npm init space -y, and it will just do all the defaults for you, and you don't have to do anything. I find that to be the easiest, but if you just hit enter, it will just use the defaults for that, so you can just enter through it and it'll automatically create it for you. And you'll see when we do it a little bit later. Actually, probably next class, not this class. So managing dependencies in your package JSON file. After creating your package.json file, you'll be able to install your application dependencies by navigating to your application's root folder and using the npm install command as follows. So you just type in npm install, that'll automatically install everything, and you can also do an npm update, which will install any missing dependencies and will update all your existing dependencies to their specified version. We'll just kind of skip this, that's not really necessary. So node modules, as I mentioned, this is the folder where all of our npm installs are going to go, which is pretty helpful. But JavaScript has turned out, that's just buzzword. Its closure pattern and event-driven behavior have proven to be very helpful in real-life scenarios, but like all programming language, it isn't perfect. And one of its major design flaws is sharing the single global namespace. So one of the issues of when you have, like, say you have like your index.html file, and you require in a bunch of script tags onto your site. So you have main.js, you have index.js, you have do-something.js, and all of those will share the same namespace. So if you're trying to access a variable in one file and you want to access it in another file, you can do so. There's no issue. They're not siloed to each thing, which was part of an issue with just using node modules until COMMON.js had tried to solve this issue of making sure that each thing has its own namespace for like variables. So that way you aren't necessarily having like name conflicts across your different modules. So COMMON.js is a project that was started in 2009 to standardize the way of working with JavaScript outside the browser. Again, because of Google updating the V8 engine in 2008 and Node.js kind of starting in and around there, it wasn't until 2009 that COMMON.js had tried to solve that problem of a global namespace. So the project evolved since then to support a variety of JavaScript issues, including global namespace issues, which was solved through a simple specification of how to write and include isolated JavaScript modules. There's kind of like three main things that you can do. There's the require, which is where we require in a module. You have exports, which is how you export that module. And then there's also just module, which is the object, which was originally used to provide metadata information about the module. It also contains the pointer of an exports object as a property. However, the popular implementation of exports object as a standalone object literally changed the use case of the module object. So honestly, we don't actually use module a whole lot as like a keyword in our projects. The two big ones that we're going to be using is require and exports. And I think further on, as of who's familiar with the term ES6? Couple. So ES6, so JavaScript has gone through several iterations, just like any programming language. Before ES6 was ES5. And when the latest version came out, so that would be 2015 that ES6 came out, it brought with it what is called ES modules. And what that does is it tried to solve the exact same problem that COMMON.js did, but an actual standardized way of doing it inside of JavaScript. So we might end up actually using the word import and export, but it's very similar to using require and exports. It's just a little bit different. But just to let you know, if you sometimes see a different keyword, it's a different way of handling it, and is where the programming language is going in the future, but not necessarily right now. Also, can anyone tell me why JavaScript and kind of just the web in itself can sometimes be a little bit of issues of updating the programming language? Does anyone know why JavaScript is a little bit more unique than, say, like C# or Java? So the issue, not really an issue, but one of the benefits of the web is that everything is backwards compatible. So you guys kind of laughed earlier when I said supporting IE, but there's a lot of like government that still is locked down to using Internet Explorer. But the big thing is that if you created a page, for the most part, in 2000 or 1995, and you wanted to run that website today in Google Chrome, it would probably work. That's kind of the big thing about the web and makes it a little bit more complex for us as web developers in the web, is that we want our code to be backwards compatible. But the issue is we can support something going back, but when we want to write with the latest and greatest code, if someone is using an older browser that doesn't necessarily support those features, that's where it comes into being an issue. So even code that is done with ES6, which was was released in 2015, there are browsers that still don't support ES6. And since then, ES7, ES8 has come out, and we want to use these latest and greatest features, but we can't. So in doing so, if you're wanting to support as many browsers as you can, you end up having to write either older style of code, or you end up using something like Babel, which will compile it into older code. So anyway, so common JS modules we still use quite often in Node.js. An example of being if we created a variable called message with the value of hello, and we exported a function that said say hello. So all that does is it just console logs hello, and then in doing so, when we require it into a different file, we can say hello.sayHello, and it will then console log hello to our terminal or our application. So the message variable is self-contained in the hello module. So as you can see right here, we create a variable called hello, but that will be self-contained when we import the function, import that file into the other file. So hello will be self-contained, and then say hello is a method of the hello that we required. We could call this anything else. We could say var test equals require hello, and then we would just say test.sayHello. So we can name it whatever we want. What does come into being a little bit different, there's a lot that is shipped with it that you usually can't do in the browser. So some pretty useful things, as it says here, is access to the file system. In the browser, you're locked down and you're not able to read files that are on the user's computer. You're not able to obviously, you can't use anything with HTTP and HTTPS. You can't just create a server in someone's browser. That would probably be a no-no. But when you're running something on the server, you're going to want a lot more control over your application. You're going to want to be able to read from the file system, make connections to a database, all these sort of different things that is used in a project, as well as there's some cool stuff that you can do like with sockets, so that way you can keep open connections. You can do HTTP2, so that way you can send multiple files all in one go. There's a lot that comes with Node.js that doesn't with JavaScript, and these are the core modules. And they come pre-bundled, so you don't actually have to install these in order to use them. To load a core module, all you have to do, just like a module that you npm install, you can just require it in. So here's an example of requiring the fs module, which is for the file system. And what it does is it's reading a file from etc. hosts, if people know what that is referring to. And then we have what is a callback. So it's a function that gets executed when it's done reading this file, and it returns back an error object and a data object. So we just check if there's an error. If there is, we're going to console log the error. Otherwise, we're going to console log the data. So when you require the fs module, Node will find it from the core modules that's a part of Node, and then you'll be able to use the fs read file method to read the file's contents. There's also some other, well, there's quite a bit in the fs module, but of course there's a lot of different core modules that you can do. If we go to the Node.js site, so Node.js docs, and I'm going to grab version 12. There's quite a bit that's here that you can see. So in the case of what we just used there is the file system. And there's a lot that's here. There's a read stream, write stream, stats, access, append file, changing ownership, testing if something exists, all that kind of stuff. Basically, if you're a fan of like using like the commands that are on like a Linux file system, you can do all that sort of stuff where you like change ownership, moving files, all that sort of stuff. Really anything that you would do on your computer to manipulate it. So when we're developing a Node.js web application, Node.js is a platform that supports various types of applications, most popular being web applications. As I said, like Node.js can do a lot of things, or JavaScript in itself can do a lot of things. So the most popular just being like a web application or website. I've used it to create microservices that just run independently. You can also do it for like command line tools that we that we'll do in this class. One student had used create React app. That is a command line tool that's built in Node.js. There's tons of different things that you can do with Node.js, the most popular just being web applications. Node style of coding depends on the community to extend the platform through third-party modules. So these modules are then built upon to create new modules and so on. JavaScript and Node.js is, like I said, it's all open source. So there's a lot that is done by the community. A lot of people who either do it just because they love it, or maybe they're trying to solve something at their workplace and then they share it with other people. That's actually kind of where the entire React project came from Facebook. It was all developed internally, and eventually they decided to open source it and say, hey, we can share this with other people can use it, and they can potentially find issues that we're using. That's kind of the great thing about open source. I was using a project that's called Material UI. Is anyone familiar with Material Design by Google? A couple people. So Material UI is an open source project that adheres to Material Design by Google, and it gives you a bunch of React components that you can use that is just based on that. So I think it was Tuesday or Wednesday, I was using their module and I ran into a bug with one of the components. So I submitted an issue and they're like, within 9 minutes, they already replied to me. Like, this is people who are just doing this pretty much as a hobby. Maybe they're being paid by like Patreon or something like that. But within 9 minutes, they replied to me. They said, yeah, we know that this is an issue. Thanks for reporting it. Do you want to submit the fix for it? So I just pushed up the code, gave them the code to fix it. And within Thursday, it's now already in the project to be released whenever the next version comes out. So that's something that's really cool about open source. So when you guys are beginners, you're most likely not going to be contributing to open source. However, what you can do with the benefits of open source is you can see what other people do. You can go into a popular project, see how other people write their code, and you can kind of take that style or try to figure out what they're solving and try to take that understanding that they have and try to put it into your own projects. So if you're not necessarily sure how something's working, I mean, we of course Google all the time. I mean, if you don't, you're crazy. I Google all the time. But like Stack Overflow is kind of the big thing. You post a question on Stack Overflow, someone tries to help you and give you code. And that's kind of almost what open source has in its own way, is it has the ability of having a platform that allows people to contribute to it, which is kind of all what Node.js kind of started as an open source project. So there are companies that share their own open source stuff. As I said, Facebook, Airbnb, all of like the big tech companies that you can think of have their own open source projects. Chrome has a really great one that I've been using lately that's called Puppeteer, which is the ability to have a headless Chrome browser to do what is called end-to-end testing, or you can just do like simulated input as if it was a browser, or it is a browser, but as if it was a user using the browser. And all of these companies are wrapping around basic Node APIs and deliver a better starting point for application development. So with that, like I just said, Puppeteer is what I was using. It doesn't necessarily wrap around the Node APIs because there's actually a lot more that's up on NPM now that isn't even necessarily related to JavaScript. People are putting up Ruby code and Python code on NPM just because you can. I don't necessarily know why, because there are platforms to do it, but there's tons of stuff that's up there. So developing a Node.js web application, as stated, there's multiple modules that you can use. The main popular one that a lot of libraries use is Connect. So Express, which we're going to be using, utilizes Connect. In fact, if I still have that open, oh, maybe they don't connect Redis. It might not be showing. I think connect maybe might just be a npm module, which is, or not npm, node core module, which is why it doesn't show up there. But what connect does is it provides you, it has like a set of wrappers around the low-level APIs of Node.js to do pretty common tasks. In a case of here, this is the most basic way that you can create a web server in Node.js. So we require in the HTTP module, we create a server. It has a callback with a REQ and RES, which stands for request and response. We write to the head saying that the content type is going to be text plain. And then we respond back saying hello world. At the bottom, we listen on port 3000, and we just console log saying that we've started the server. So this is pretty much bare bones, the easiest web server that you can just create in Node.js, but it doesn't do much. So in order to run our application that we have on the on our machine, we just type in node server. Node is just the command of saying that we're going to be using node, and then server would be the file that we just wrote our code into. So in this case, it would be server.js, but we don't have to add JS as the extension type. And once doing so, if you open up your browser to localhost 3000, it'll just say hello world. So I'm just going to copy this in, and then it's been an hour, so I'll just let you guys go for a break. So if I were to copy this, and I'm going to boot this up, I'm going to create a file called server.js. And close that. So here's our server.js. Let me also bump up the font size to 18. Can you guys see that fine in the back? Cool. Maybe a bit more. So as I said, we require in HTTP, create our server, list on port 3000. When our server gets hit, this happens, and we console log. So if I just type in node server, node server JS. Why is it just ending immediately? Always good. It's not doing like a kill all node. Huh, it's just ending immediately. Usually it doesn't do that. I don't know what is going on. Oh, no, I didn't. I thought I did. Thank you. There we go. Now it's working. Usually I have autosave on, so I don't know why I didn't do it. So in this case, whenever we hit the server, we say hello world. If we restart the server, I can just put in here and just console log server was hit. And if I put this to the side, this to the side, restart the server, refresh, you'll see server was hit. In fact, you might be questioning why it was hit twice. This actually bugged me the very first time that I did this as a demo. I didn't know why it was being hit twice. Anyone want to just take a quick guess of why it's hit twice? So I'll show you every time if I hit refresh, it's twice, 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 twice. Anyone want to take a wild guess? We can pretend this is bonus points. So this is not because we receive a message and then send a message, so it's not a back and forth connection. In fact, it's something that's actually just with Chrome. So you'll see if I open up my inspect element and I go to console. Actually, right now I think I have a service worker that's here, so let me just clear my cache. Application, that's all bypassed. Oh, come on, it's not. Okay, anyway. The reason why it's being hit twice is, you guys know what a favicon is? Or favicon, whatever you want to call it. Your browser, by default, will automatically try to grab a favicon when it hits a website. So in this case, because every single time that the server gets hit, I'm just console logging this. So if I actually console log the request dot, I believe it's just path name that I can put in. You can see when I refresh, no, it's not that. And you'll see right now, every single time that I make a change to the server, I actually have to restart it. In PHP, when you make a change to a file, it happens right away as soon as you refresh. C#, when you're debugging your application and running it, you have to restart the server. Node is the exact same way. But there are some tools that we can use that as soon as we change a file, it will restart the server for us. So right here is a bunch of information that is not important. So .url, we'll just use that one. So .url. So when I refresh, it's hitting the index file, which is going to be like index.html, and then it also responds back with tries to hit the favicon. So that's why it's logging twice, just to answer that. But sometimes that can be a little bit confusing of why our server is being hit twice. So as I said, this is the quickest server that we can set up, and we're going to be doing some more complex routing that we can do later on, but this is pretty simple. So we run that on localhost 3000. How it works, as I just said, application, we did that. So there's, as I mentioned, there's the connect module. So the connect module is built to support interception of requests in a more modular approach. In the first example, you learned how to build a simple web server using the HTTP module. If you wish to extend this example, you'd have to write code that manages the different HTTP requests sent to your server. So in that case of when we are hitting both the index file and the favicon, we would need to write our application to being able to split those up into different requests. We don't always want to respond back with the same information for every single page that is hit on our website. And that's what Connect does for us. So Connect creates an API exactly for that purpose. It uses a modular component called a middleware, which allows you to simply register your application logic to predefine HTTP request scenarios. So in this case, if you go to YouTube and you go, /u/ or let's do Reddit, which is pretty easy, /r/ and then you put in a subreddit name, it automatically, you can put in a pathing that would be /r/ and then it would be a variable. So in there, that's when Reddit would be able to determine where you need to be redirected upon hitting that URL. So the Connect middleware is basically a bunch of callback functions which get executed when an HTTP request occurs. The middleware can then perform some logic, return a response, or be called to the next registered middleware. So there's a lot of complexity that you can do in your application. You can do some sort of logic where when this happens, I want to hit this middleware, otherwise hit this middleware, et cetera, et cetera. And while you will mostly write custom middleware to support your application needs, Connect also includes some common middleware to support logging, static file serving, and more. So we'll kind of just go over that later. I'm going to allow you guys to go for break. Right now it's kind of like 10 past. So if you guys want to be back here, say, what is that, 7:20, 7:25 roughly. And then we'll just quickly go over this. And then we'll start doing some practical stuff when you guys come back, because I know how boring this is. I apologize. Okay. So if I refresh, it'll say hello world. If I go to something else like /hello, it still says hello because we haven't set up any sort of routing in our application. So app.use is a middleware that we have set up, and basically that will run upon every single route that ends up getting hit. So if I go later, saw that. So mounting the connect middleware, as you may have noticed, the middleware you registered responds to any request regardless of the request path. So if I go to something that is really long, I can just type in whatever I want, and it will still respond back with what is there. This does not comply with modern web application development because responding to different paths is an integral part of a web application. If you went to any sort of URL on like YouTube, and it always responded back with the same thing, you'd be pretty frustrated. You'd hopefully want to get your video that maybe someone sent you, or managing your profile or something. Fortunately, Connect middleware supports a feature called mounting, which enables you to determine which request path is required for the middleware function to get executed. So mounting is done by adding the path argument to app.use. So if we change what's here, so this is a little bit small, so I'll just copy this into Visual Studio. So we're still requiring in Connect. We're executing Connect. We have a logger. We'll keep that in. So we have hello world and we have goodbye world. So in this case, app.use is the first part of our application. It's the first instance of something being used. So every single time that something hits our application, it's going to hit this first. In this case, we have app.use on /hello. So if we go on our application and go to /hello, we are going to set the header of content type being text plain and respond back hello world. Otherwise, if we go to /goodbye, it will then do the exact same thing, but it'll say goodbye world instead. So right now, if I type that in, it says it cannot get because we haven't set anything up, but you can see down here, we're logging out where the path is. So if I type in /hello, we say get hello, it says hello world. If I say goodbye, it says goodbye world. So that is automatically working. Now, something else that you can sometimes do is just type in, you can use a colon and then whatever variable name that you want, and then you can actually start having like ID paths. So in the case of YouTube, they're not going to manually set up every single link that is possible. You have some sort of variable that will be handled behind the scenes. But because I've now set up this generic ID, it's probably never actually going to hit goodbye. So if I refresh, oh, it still is. What if I type in hello? Does that? Cannot get hello. Okay. So IDs don't work that way in Connect. That's Express only. We are going to cover that in a sec. So Express. So Express is a small set of common web application features kept to a minimum in order to maintain Node.js style. Usually a lot of modules that you install kind of only do like one or a subset of certain things. It's built on top of Connect and makes use of its middleware architecture. Its features extend Connect to allow a variety of common web application uses, such as the inclusion of modular HTML template engines, extending the response object to support various data format outputs, a routing system, and much more. So here's an example of using it as a replacement of what we just did with just the hello world, using just Express instead. So I'm going to paste this in. And right now it's breaking because we have not installed Express. So I'm just going to npm install --save Express. And by the way, don't worry, all of this will be on GitHub. I'll post it at the end of the class. So if you want access to any of this code, we'll put it in. So I've installed Express, and now I can just run npm run dev, and it's running. So if I refresh, we're still working. So right now we just have /hello world. I'm surprised that it worked with just anything. Okay, cool. Oh, I see what's possibly going on. No. Okay. But with this, you can see compared to before, we had to manually set the headers for the content type that we were going to be sending. In this case, we don't have to do it anymore. And it actually has a lot of different features that make it a little bit easier. So instead of just using send, you can just say res.json, and you can give it, so I'm going to say hello world. If I refresh, right now I have a Chrome extension that formats for me, but it will automatically let the browser know that the content type is going to be an application JSON. So there's a lot of handy functions that it handles behind the scene for you, which is why we're not going to be using just HTTP by itself or the connect module by itself. We're going to be using Express because it just removes a lot of that complexity that we don't necessarily need to handle as web developers. We can just throw it out the door, make it a lot easier for ourselves. Because otherwise you're going to have to do a lot of it yourself. And at the end, you're going to be like, well, can't I just write a function that just automatically knows if it's a JSON format or if it's HTML or if it's text? And that's exactly what Express is doing. So by going to the next slide, Express presents three major objects that you'll frequently use. So it has the application object, which if I put this side by side, so it has the application object similar to what we just used with Connect. So you have var app. This is the instance of our Express application. So you can think of it as the everything that our application does as a whole is going to be in there. And then same thing as with Connect, we have the request object and the response object, which is like the client sending to the server and what the server is going to send back. So each of them have their own use cases. So with app, this is where we would set up, we want our application to do something on this route, or we want something to do it on that route. Whereas inside of our callback that's right here, we say that we want to respond back with this type of code. So we're not saying we want the application to respond back. We say we want the application to intercept on this path and respond back with this. So the other thing that the application object also has the ability to do is you can set like variables across your entire application. So you have app.set that gives you a name and then a value. So you can set something that would be specific to your entire application in there. And then of course you can use app.get to get that variable. You also can use app.engine, which would be used for what your templating engine would be. There's a ton that is out there. You can use EJS, you can use Pug, Jade. There's tons of different ones, handlebars. But for the most part, we're probably either going to use Pug or nothing at all. We're just going to respond back in JSON format so that way we can use that with our front-end framework. Then we have app.locals, which are used to send application level variables to all rendered templates, which can be pretty handy, so that way you don't have to pass the same stuff in your application. You have app.use, which as we saw before is like a middleware that will run for anything that is valid for it with a path that is optional. You have app.verb, so as you guys know, there's get and post for HTTP methods. There's a ton of other ones as well. There's like delete, put, post, options, some other ones that I'm probably forgetting, that all have their own specific use cases. So you can do something specific to just what the HTTP method is. So that way, someone doesn't do a GET request to your thing and you start creating new content. You don't necessarily need to do that. You can only do it for just a post or just a put. App.route is kind of similar, but it will cover all the bases. So anything from GET, put, post, you can do that if you so wished. And then there's also app.param, which is more deprecated, but it's the ability to get, I'll just read this just because it's easier. This is used to attach a certain functionality to any request made to a path that includes a certain routing parameter. So this is where you could do like certain validation on a parameter that is in your application. So if you're requiring in an ID, you could make sure that that ID is numeric, or if you could make sure that it's greater than 0 and respond back an error so that you don't have to do that same sort of validation in every single route that is hitting your application. It just makes it a little bit easier if you wanted to, but there's not a lot of use cases that I've used it on lately. Yeah, so that's mostly it. That's the slide. Now I'll go over what is Lab 1. So Lab 1, hopefully you guys know how this works, but the assignment is going to be rock, paper, scissors. Who here does not know how to play rock, paper, scissors? I hope everyone knows how to do it. I think it's pretty universal. But the assignment is going to be creating rock, paper, scissors in JavaScript. This is used mostly so that I can get a good grasp of where you guys are. But it obviously is still part of your final mark, but it's pretty easy to do if you know how to write JavaScript, but it should be something that comes secondhand. You know that rock beats scissors. Apparently this is really hard to remember off the top of my head, but the rules are pretty simple, and it's just more the logic that you end up having to write inside of JavaScript. So if I open up the submissions, there is a Word document that describes all the rules for it. So we're going to be writing this in JavaScript, obviously, and what the program will do is it will ask the user if they want to choose rock, paper, or scissors. I don't care what way you do this. So this lab is fully optional if you want to either do it in a web application, like with an index.html, and you require in a JavaScript file, or if you wanted to do it in Node. You can do either one. It doesn't really matter to me. If you're doing it in Node, most likely you're going to be like reading from the console in the same way that you would like in Java or C#, where you do like print line and then read the input from the command. Or you could just use like a web. You could do it with clicking on an image. You can use radio buttons or any sort of thing. That doesn't matter. But what does matter is that the user has to choose rock, paper, scissors, and it handles invalid input, so they can't choose something that doesn't exist. And the computer will be randomly assigned. So winning combinations, as I started saying earlier and forgot how it goes, rock beats paper, scissor beats paper, paper beats rock. The program should indicate who the winner is, and the program should be written completely in JavaScript with no libraries. And by that, I mean, please don't find like a rock, paper, scissors module online and then just require it in and you're like, I'm done. That doesn't show me your ability. There will be time to use other modules so that we don't have to redo the same thing. But as I said, the code can either be intended for the browser or intended for Node. You're welcome to do either one. It just has to be working and on GitHub when you submit it to me. And there's kind of like two small issues that it will have to handle, which is, like I said, the player choosing an invalid option. If you're using the command line, you can either have them manually type in rock, paper, or scissors, or have them type in like a number system where like 1 is rock, 2 is paper, 3 is scissors. But if I choose 4 or 0 or ABC, it should automatically handle that and then ask me for a different input, saying that's not a valid option. It should also handle a tie. So in the case if the player and the computer have the exact same option, it should ask them to rethrow, because nobody wants a tie. We need a winner. We only like winners here. No, I'm just joking, but like you do have to re-ask. So there is also an option for a bonus. So here's the one thing. If for some reason you can't get this done by next Monday, which this is a pretty straightforward lab, you do also have the option for bonuses to make up if you have to submit it on Tuesday or Wednesday, and you could still get full marks because it gives you so this is out of 2.5, and you can get an additional 0.5 up to 3, so that's a fair bit right at the beginning. So you do have the ability to make up for lost marks if you end up messing something up, or submitting it late, or you could just get over 100%, which is cool. But what that bonus is as soon as you get the winning or losing result, whatever it is, it should ask the user if they want to play again. And in that case, it will then, ask, do you want rock, paper, or scissors? And as soon as you're done, once you say, no, I don't want to do any more, it will then display how many wins, losses, and ties there were. So even though you have to, the requirement without the bonus is you do have to handle that tie with a rethrow. You still have to, for the bonus, log how many ties there were and then display it at the end. Does anyone have any questions thus far about the lab? I hope it's pretty straightforward, but I wanted to be very specific on what I'm wanting. Yes?
If we already know a library, can we use one?
What do you mean for a rock, paper, scissors library?
No, like front-end library.
Oh, yeah. If you want to use like React or Angular or something like that, that's totally fine. Just as long as none of the logic for rock, paper, scissors is handled by a library, that's totally cool. I had another student who asked me if he could do it with socket.io just because. I was like, yeah, go crazy. I mean, like, I know that some people are going to be coming into this class already with Node.js experience or React experience or some sort of experience at a higher level. You're welcome to challenge yourself as much as you want. You can make it as pretty or as ugly as you want. I know some people like to design stuff up and make it really cool. Please just make sure that the functionality is working before you make it pretty, because otherwise I'm going to remove marks because you didn't have it working. So hopefully, does anyone here not have like a computer that's working right now? You guys all have working computers? Okay, cool. So I'm going to be going through part of it right now. I'm going to be doing it from the Node side and not from the front end side because that's what we're going to be doing in this class. But if you're wanting to follow along, you can probably get at least like just the main part. I'm not going to do the bonus in class here because otherwise there's not a point in me giving you a bonus. So what I'm going to do is I'm going to kill the Node server. Oh, also you don't actually have to do Node as in like a website. I'll show you guys in a second how the read line module works. But you don't have to like have a website running and all this sort of stuff. It can just be purely through the command line. You never once open Chrome. Yes?
Sorry, socket is not working here, so.
Yeah. All I can say is maybe try to plug in somewhere else. I don't know who I would talk to about letting them know, but I'm sure I wouldn't be the first one. So, the one thing, and I'm sure you guys might even know by now, to be really like any kind of web developer, reading is super important. A lot of these different programming languages, of course, are going to have extensive documentation and can sometimes be a little bit overwhelming. But if you just type into Google kind of what you're wanting to look for, like in this case, I'm going to be wanting to read a line from the terminal. So I just type in read line, Node.js, and you pop up to the Node.js v12 documentation, and we have this read line module that we can put in. So that's going to be the first line of my project is I'm going to require in the read line module. Then the next part that we want to do is we need to create an interface. So what that interface is doing is we need to know where input is coming in and where output is going to go out. In this case, we're going to just be using the process standard in and standard out, which is basically where that file is being run. In this case, we're going to be running it in the terminal, so it will expect input and output from the terminal. So I'm just going to copy that. Cool. So create interface to read and write. And then it has an example down here of creating a question. So let me just make this full screen now. So I'm going to remove that. Actually, I'll keep that up. So if I run this code right now, if I type in node lab1.js, it says, what do you think of Node.js? And some of you might be saying that it sucks. Which is okay, because like, I mean, you can't like everything, but this is a mandatory course, so you're SOL. But hopefully we can try to like change that by the end of this class. But in doing so, you see right here that it says question, and we give it a string value of what do you think of Node.js? And then it has another callback that we saw before. In this case, it comes back with an answer, And inside of there, we then execute this code where we console log saying, thanks for your valuable feedback. We render out the answer that they gave us, and then we close our interface that we created with readline. So ask question, and then execute code after getting answer. So that's pretty straightforward, I hope. Is anyone a little bit confused on how that's working? I mean, you might not necessarily understand what's happening fully behind the scenes, but like, is that pretty straightforward? I guess yes. But the only thing is we need to ask the user to choose rock, paper, scissors. So I'm going to say, please choose one of the following. Say rock, paper, and scissors. And just to let you know, I am using what is called the backtick. So I am able to use a single string across multiple lines. So if you're just using like a regular single quote or double quote, this is not going to work. So you can just use the backtick, which is beside the 1 key on it. And I guess the other thing that I'm just going to quickly ask, did you guys go over fat arrow notation in your JavaScript frameworks class or any of your JavaScript classes? Yes, no?
I think so. Like the
Arrow function?
arrow function.
Yeah, arrow functions, fat arrow. So just really quickly, before, in order to create a function previous to ES6, you had to type in the keyword function, use your parameters, and then use the curly braces, and then you could write code in here. So like I could do console.log, hello world. And you can do two different things. You can either do a named function of hello world, or you can create a variable called hello world and assign it to that function, which would be called an anonymous function. Basically a function that you cannot call by itself because it doesn't have a name, so you assign it to a variable. So in this case, if I just executed hello world right here, so as soon as we type in our response, it says hello world because we called it right here. We can do the exact same thing with the arrow. So this is an arrow function. So it just makes it a little bit easier. Programmers are lazy. We don't want to type the word function over and over again. So we just implemented it for some reason. There's a little bit of differences, but as opposed to like a regular function, but for most cases that we're going to be doing here, there's not really any difference. So the one thing that is a little tricky is if I were to put this code in a while loop, it would continually ask us the same question over and over and over again without waiting for a response. And the reason for that is because with our callback, it's expecting a response, or sorry, it has code that will be executed once it gets a response. So if we were to just throw this in a while loop, it would continually just do the question part without waiting for a response. You wouldn't be able to type it in. It would just keep clearing it from you. So there's different ways that you can work with asynchronous code. The one way that's more popular now than using callbacks is using a promise. So what a promise does is it's very similar to a promise in real life. You say that you're going to do something, and then hopefully it comes back saying, yes, you did it, or you can also catch it, which is when it comes back with unexpected output. So what I'm going to do is instead of using this as a callback, I'm just going to convert it into a promise. So I'm going to say const question equals new promise resolve, and then we're going to actually, hold on, I'm going to take, so we want our question to be a question text right there. And we're going to do rl.question with our question text. And then our answer, we want to resolve the answer. And this code, for those of you that probably have worked with JavaScript before, this is a little verbose. You can simplify this, but it makes it a little bit more tricky to understand at a beginner. So what this ends up doing, this is probably a little bit confusing still though, is we create a variable called question. And then this accepts a parameter that's called question text. And this is going to be our text that is right here. So we give that, and then we want to return a promise. So that way, when that promise is done, we can resolve back what the answer was. So if I were to change this, I could now just change it to just question. And instead of having this callback, I can now say dot then, and it gives us our answer. So I can get rid of that, get rid of that. I think I have an error here somewhere. Oh, yeah, right here. There we go. So very quickly, you can change something that is a callback into a promise, doing what is called promisifying, which is where you just convert a callback into a promise. So now if I run this exact same code, it still works the exact same. It waits for our response to come back, and then it will console log to the screen. Now, you might be asking, why did we just do that? And the reason why we did it is working with a while loop with asynchronous code is one of the worst things to deal with. If you want to work with asynchronous code and a while loop, you actually end up having to do recursion, where you call it self if it doesn't meet the expectations, and you keep doing that over and over again, which is needlessly complicated. We want to try to do this as easily as possible. So what we're going to do is I'm going to create a function that's going to be called game, and this is going to be an async function. So this part of it being an async function is pretty important. The reason for this is instead of using a .then on our promise, we can use the keyword await. And await can only ever be used in an asynchronous function. So now what we can do is, and here's the other thing, is it changes the syntax a little bit for a promise. If you're using a promise by itself without async await, you always have to use .then to wait for the result to come back. So you do something, and then when it comes back, I want to do this. Kind of similar to a callback. But using async, you can await that result without having to chain off of it. So I can say const choice equals, and I'm just going to say question. So I'm just going to copy that. I'm going to remove this out. And I'll put this right here. And I'm also just going to, no, that should be good. Okay. So we have our choice. It executes the question, which returns a promise. But right now, it's not, well, when I have to execute our game, we want to say game, execute it. But it's not going to actually wait for it. Just because we put in async doesn't mean that it's going to wait. So if I just run it, let's do that one more time. Nothing happens. We're not doing anything with it. So what we want to do is we want to, or hold on, let me just console log choice. So if I run that, you'll see that we get a promise pending. So this is coming back with a promise, but it hasn't actually resolved yet. So I can just type in something, but nothing. It's too late. We've already executed the code. So what we do is we throw await in front of our choice. And then now when we run it, we can now type in scissors, and it will now execute that asynchronous code because it has waited for the promise to resolve, and now we get that choice. So now we're able to take, and this is the benefit of using async await, is you can now take something that is asynchronous and write code that is synchronous. So it allows you to use the benefits of both synchronous and asynchronous code. And the reason for this is we want to continually ask the user if they haven't given us a valid option. So I'm going to create a constant that is going to be called valid options. And this is going to contain the 3 options of our game that we're going to consider valid, because otherwise it's a lot harder to, like, we're not going to blacklist every single option that is invalid because there's going to be way too many. It's a lot easier to just say what is valid. So in this case, we're going to do rock, paper, and scissors. And I am going to console log if our valid options. So valid options is an array which has a method on it that is called includes. So I can say if our valid options includes the choice that we just did, we're just going to console log, and this will either console log true or false. So check if choice is in valid options. So I'll just throw that to the side. I'll also close that. So if I run this right now and I type in paper, we get true because paper is in our valid choices. If I type in snake, that's an invalid option. So what we want to do is we want to continually ask them until that choice is invalid. So we can just change this up a little bit. So we want to have our choice, which is going to be null. So note that I've now changed it from being let, or from const to let. So I think you guys probably have gone over what is const and let, but very quickly, const cannot be changed. It's kind of similar to like final in Java and C#. Not quite, but like a little bit. Whereas let is very similar to var and allows you to be able to change what its value is. So now instead we can just do choice equals that, and we can say while, let me put this inside the while loop. And we want to say, we want to take this thing. So while valid options includes choice, and we want to make sure that it does not contain our choice. So we want to continually ask them while their choice does not contain, is not inside valid options. So I can now just get rid of this. So I'll just throw this comment right here at the while loop and remove that. So now if I run it and I type in snake, that's not a valid option. We would probably also want to give them an error saying that they entered an invalid option, but we're not necessarily going to do that right this second. You're welcome to do that actually in your lab. But if I type in rock now, it console logs rock. So that's pretty much halfway there. We've now been able to take input from the user using node in the command line for taking their input. So now what we also have to do, and I almost encourage this just because it's easier. If you haven't heard of MDN, it stands for the Mozilla Development Network, and it has a lot of documentation for everything from CSS, HTML, and JavaScript. It's pretty much the go-to resource, including like Google, as well as like Apple. Like all of these big companies help contribute to MDN because, again, it's also open source. So if there's documentation that is incorrect, or maybe they want to improve the wording of it to make it more clear for newbie programmers or even just experienced programmers who just want the TLDR of what to do, this is the site to go to. So I'm going to take this function that's right here just because I know it's there, and it is a get random integer that you can give it a max value. So I'm just going to copy it into our code. So what this does is it does a random math.random, which returns 0 through 1, and then we multiply it by our max value. So that way we can get a result between like 0 and 3, or in this case we actually want 0 and 2, and then we floor it so that way there's not like any sort of decimals, and we also end up flooring the max result as well. So this will return us a random integer, and we want it between 0 and 2. Does anyone know why we want to return a random integer between 0 and 2? What?
0, 1, 2. Start with 0. You want to return rock, papers, or scissors. We want to take one from the array.
Yes. So we already have an array of what our valid options are. So why don't we just generate a random number to return an index from that array? So as Vlad was saying, we can just right here. So in our game, sorry, the formatting's just a little weird. So inside our game, we just say const computer choice equals get random int. We want a max of 2, and we want to return valid options at that index. So we say this will return 0, 1, or 2, and we return either rock, paper, or scissors from valid options and assign that to computer choice. So now if I console log out the computer choice, not our choice, but the computer choice, if I rerun that and I type in paper, computer by chance happened to get paper. But if I type in paper again, they now got rock. So if you were to compare rock, paper, and scissors on our end and rock, paper, scissors on the computer end, how would you end up comparing that? The easiest way would probably just be like an if statement. You could end up setting up you could overcomplicate it and set up game rules and say if we chose rock and we did this, automatically handle it. But we're just going to do an if statement. And the first one that is really easy to do, there's also one bug, but we'll just leave it for now because it's not a big deal, but we'll circle back to it in a second. We just want to do the comparison. So the first and easiest one to check is if there's a tie. We just have to compare our choice and the computer's choice and see if it's the same. So in this case, we'll just do choice, and we'll check if it's equal to the computer choice. And if it is, we'll say console log, there was a tie, and just do that. Otherwise, we want to check if, and we're going to do that the player won. So in this case, it would be, else if choice equals rock and computer choice equals scissors, and we'll just paste that a couple times and throw in some or statements. So if we chose scissors, then we beat paper, and if we chose paper and they chose rock, those are all the possible winning conditions. So just throw in a comment, rock beats scissors, scissors beats paper, and paper beats rock. So in here, we can just say console log the player won. And then if it's not a tie and the player didn't win, then the very last thing that's possible is that the computer won. So we can just say console.log the computer won, and we'll just remove this choice that's right there. So now if I run it and I type in rock, there was a tie. If I type in rock again, the computer won. So this isn't too helpful, just in the fact that we can't see what the choices are. So I'm just going to throw those in. So I'll say, so the player won, player chose choice, computer chose. Actually, you want to? I could probably just keep this all on one thing. Hold on, I'm just going to copy this. So in any case, doesn't matter if we tied, won, or lost. At the end, we just want to console log what both choices were. So outside of our if statement, I'm just going to display what those results are. So we have choice, computer chose, computer choice, and should be all good. Run that. So now if I type in rock, there was a tie, we chose rock, computer chose rock. One of the things that's a little bit annoying about rock, paper, scissors is there's very few options to choose from, so there is the potential to constantly tie over and over again. So if I type in rock, a tie again, type in rock, player chose paper, Player chose paper, or sorry, computer chose paper. Chose it again. It seems to only be chosen between rock and paper. I have a feeling that there might be a small bug in this. So instead of requesting with a max of 2, it might actually be assuming that when we give it a max that that is the number that we don't want. So it's probably only doing between 0 and 1. So we can just change that to 3. Or what we could just do is keep this as still we want 2, but we're just going to change our max to +1 up here, which makes more sense. Because at least how I'm assuming this is I want between 0, 1, and 2. So if I run this one more time, I type in rock. The computer chose paper, so the computer won. So does anyone know what the bug that I might have mentioned before is, and I will show you the exact line, is this while statement that's right here. Can anyone try to tell me why there's a bug? Yes, exactly. So right now you'll see that our valid options is rock, paper, scissors, all in lowercase. But from a usability standpoint, someone is seeing that they're given the options of rock, paper, scissors with a capital letter at the first letter. So if we were to type in exactly what is on the screen, and we type in rock with a capital R, it assumes that it's an invalid option. And the reason for that is it's case sensitive. So we want to make this case insensitive. So what we can just do is convert whatever their option is into lowercase. So what we can just say is case. The other thing that we're going to want to do is you can also see down here that we have choice is rock, paper, scissors as well. So what we're going to do is just say choice equals, or we can just do, yeah, we'll just do that. Choice equals choice dot to lowercase. So the reason why we can't, like normal strings, is we can't just do dot to lowercase after the question, is because technically it's returning a promise. And that would be executing to lowercase on the promise. This is why sometimes asynchronous programming can be a little bit confusing, but I promise that it does get easier. But we could also do a promise off of it. So we could say await question, and then we could do then, and say answer, and we return back answer.to lowercase, which does the same thing as this, but we're not going to worry about that because it's a little bit more complex. We're just going to, for all sake and purposes, wait for the choice to come back and then convert it to lowercase right after. That's the easiest thing to do. So we want to convert to lowercase for our valid option check, case insensitive. So now, when I rerun the application, I can type rock all in capitals, and it will automatically convert it into lowercase. Actually, you wonder what? Oh no, I was typing in rock lowercase before. So the reason why that causes two issues is if we only took the choice that's right here in our check, so this is checking if it's valid, if we only converted choice to lowercase, it would start to cause a bug down below where we are doing our logic for the game. So in this case, we end up checking if choice is triple equal to rock with a lowercase or scissors or paper with a lowercase. And if we manage to only put it up here, then the computer would always win, no matter what, because that's kind of how we've set up our logic. So something else that you could do if you wanted is you could set up the other statements that would be the winning logic for the computer. And then you could do an else statement and just say like there was something that messed up because we've handled all the other cases. But we're not going to worry about that. Just else statement, the computer won. Does anyone have any questions about what we've done so far? Yes?
It's not a question regarding what you did, but is this going to be on GitHub as well?
Yes. Yeah, I'll throw this up on GitHub. Please do not just copy paste it. This is like an example for in class. But I'm not going to be covering, like one thing that would be nice is if you put in an error message, if it's not a valid result, you should do that, as well as I'm not going to be doing the bonus in class as well. But with that, I think that's pretty much everything that we should cover today. Yeah, does anyone have any like other questions? No? Okay. So, oh, yeah.
Yeah, you're not gonna put that on Blackboard, are you?
Sorry?
You're not gonna put that on Blackboard or GitHub, are you?
Yes, yeah, that was just what was asked. I'll be putting this code onto GitHub. Like I said, please don't like use it as a reference, but not copy paste it. As for the actual like classes, just let you guys know sometimes it can take a little bit to get it onto YouTube. I live stream it to YouTube, so the moment that I'm done recording, it's technically on YouTube. But just for putting in like the description and title and all that sort of stuff and putting it in the playlist, with this being later at night, it takes me about like half an hour, 40 minutes to get home. So it will probably not be done until the next day. So allow like 24 hours for it to be put on YouTube. And I will always be using Slack to let you guys know that the latest video has been uploaded to YouTube. So instead of sending you guys like a weekly email letting you know that class is now on YouTube, I'll just be posting into Slack. I have the ability in here to, let's see, here's our class. So the other thing is I've set up 2 channels. I have a Monday channel and I have a Tuesday channel. So obviously with you guys being in Tuesday, if there's anything that is specific to this class, I'll put it in Tuesday. And then if it's Monday, obviously the Monday class. And then everyone just relates to everything. So I'll just do like I have the ability to do @channel, which will send you a notification if you guys have it on your phone and have that enabled. Just so that way you guys know that I've posted on YouTube, or I might, you know, if I send something else that's important to the class, I'll also just send a message in there just so people know. I encourage you to be in Slack. I think we only have 36 people in Slack, and this is for both classes, and I have 40 students per class, so we're at under half. So I encourage you to be in it. Yeah. I'm just trying to think if there's anything that I missed to cover in this class. I think that's everything. Yeah, does anyone have any questions either about the class in general or what we covered? I know I asked that a lot, but I just want to make sure that people are all good.
Is the Slack channel URL in Blackboard?
It's not, but I sent an invitation to everyone's student email address with their student number at gc.georgianc.on.ca.
Okay.
So I've sent that to everyone. I can also post the link into Blackboard. That way, if you want to sign up with like your personal email address, an email to one email, so it was easier. But yeah, so this is pretty easy to being able to communicate with people. I have Slack open 9 to 5 because I use it at work. As you can see on the left side, I have a fair amount of channels or workspaces that I'm in. So if you send me a message, I'll probably see it right away. I might not respond right away, even if I'm online, but I try to be as quick to respond as possible. And also, if you could change it so that your username is not your student number, so that way I know that you're a human being and not a robot. It's good, because we're not all robots, hopefully. That's it. You're free to go. I'll keep rambling if you stay here, so just go. Yep, one sec. Let me just finish off the recording.